You're always going to start the same way. You're going to look at the formula an plus 1 over an, absolute value, but this is another case where the formula is positive. So again, the absolute values don't matter here, but let's develop good habits. So just so I get you out of here on time, I'm just going to fill in the n plus 1 wherever the n is to get an plus 1. So absolute value of, it's 2n plus 1, and then the whole thing factorial, so I guess you'd have to write it like that. Or right away write 2n plus 2 parentheses factorial. Over n plus 1 to the 5th. That's just an plus 1, and then I'm going to flip and multiply, because really I'm multiplying an plus 1 by 1 over an, so I'm going to take the reciprocal and multiply, which gives me n to the 5th over 2n factorial, close absolute value. Does everybody believe that so far? Let me rearrange things. I'm going to drop the absolute values because everything's positive. 2n plus 2 factorial on top. I'm going to move the 2n factorial right beneath it. And then I'm going to write n to the 5th over n plus 1 to the 5th together. And again, I dropped the absolute values on purpose. Okay, here's what I want to see. I want you to write out, I want to see the cancellation here. So write out 2n plus 2 factorial is going to divide with most of the with all the terms from 2n factorial. You'll have a couple things left over. So 2n plus 2 factorial, remember, is 2n plus 2 times 2n plus 1 times, do I go any further? 2n, I don't need to go any further, right? Does everybody see what I'm doing? I'm rewriting this guy in terms of at least one factor that'll cancel with this guy, which I did. It's this guy right here, right? So then that is all over 2n factorial. So I'm trying to simplify this, get rid of the factorial. And then I still have the n to the 5th over n plus 1 to the 5th. So does everybody see the cancellation? I want to see that to make sure you know how that works. And then that leaves me with what? 2n plus 2 times 2n plus 1 times n to the 5th, all over n plus 1 to the 5th, or you could keep that separate if you wanted. Okay. Here's another one I'll give you for free, as long as you know how to explain it. If you were to multiply this out in the numerator, what degree would it have? 7, right? Because you have n to the 5th right here, and then this is going to be a quadratic factor. Multiply it out. So degree 7 on top, what on the bottom? Degree 5. The degree of the numerator is greater than the degree of the denominator. What's going to happen as n goes to infinity? It's going to diverge to infinity. You should be able to explain that if I ask. And the explanation is the degree of the numerator is greater than the degree of the denominator. Okay? Well, let's see. Is infinity bigger than 1? Yeah, last I looked, it's bigger than 1. So the conclusion is what? So the series does what? Diverges. We don't say diverges absolutely. It just diverges by... Don't say RT because there's a root test too. So you got to write it out. Ratio test. There's a root test which has the same initials, so you got to write it out.